from SolutionsIQ. So he would basically introduce Joe and SolutionsIQ.
Thank you all. My name is Vibhu. I am a coach and work with SolutionsIQ. And without any delay, I want to introduce you to Joe Justice. And he's going to probably introduce himself better than I will introduce him. So Joe, with no delay, we would like you to welcome here and talk about whatever you want.
Thank you so much.
Awesome. It's so great.
Test. Can you guys hear just fine?
Yes.
Okay, good. I'm Joe Justice. I'm a business process consultant from Seattle, Washington, in the United States. If this were a map of the United States, Seattle, Washington is here in the top left. At night and on weekends, I'm the CEO and the team lead of a company and volunteer organization called WikiSpeed. We built a fast, affordable, ultra-efficient car, and the first running prototype of that car was built in only 3 months. How is that possible when the cars around us seem to change so slowly? Here we see a mainstream hybrid sedan, and across a 6-year time frame, it gained an additional 2 miles per gallon. Visually, it remained almost identical. Traditional manufacturing changes slowly because the cost to make change is so high. Here is a door being formed at Tesla's Model S factory, a brand new facility in California. This black metal here is called a stamped steel die. It's machined out of metal, and then doors are pressed into it. This is a typical manufacturing method because the unit cost, the per piece cost, is very low. This stamped steel die costs about $10 million to iterate. That means if an engineer had a safer door design, a cheaper door design, or a more ergonomic door design tomorrow, the company would want to wait many years to first pay for the existing door mold before making a new one. This is directly in opposition of innovation. This is common in manufacturing organizations, and it's the way older software teams used to run. They would go through the development life cycle and then deploy and release their product, which was the only time they were recognizing revenue. According to cost accounting, all of the innovation process was considered an expense, so they would do it as rarely as possible. Porsche has announced that the current generation Porsche 911 sports car will be relatively unchanged for 14 years. Parts of that car were designed in 3 years. Parts of that car were designed in 11 years. That means you could go to a Porsche dealer and buy a brand new Porsche 911, and it would be the best car the engineers thought you might want 25 years ago. New software teams, or agile software teams, do the same cycle, but then they repeat on rapid iteration. Many times, these iterations are now 1 week or even less. This means new products are based on what we believe the customer wanted 7 days ago. This is only affordable in hardware if we treat hardware like software. That means we use responsible design patterns and loose coupling. The WikiSpeed car, before we could iterate it affordably, had to become modular. The car is composed of 8 modules that can change independently. We can change the body from a roadster to a pickup truck. We can change the drivetrain module from gasoline to electric in about the time it takes to change a tire. This means we can iterate the entire car in hours. If we were trying to iterate a traditional car, it would take a very long time. If we were trying to iterate a piece of procedural software with no classes that was tightly coupled with cross-references throughout, it would be very expensive to iterate. First, we would have to erase that technical debt by introducing proper design patterns. By by applying proper design patterns, we're able to iterate inexpensively and quickly, even in hardware. We call this extreme manufacturing, or XM. This is to say thank you to the extreme programming community that pioneered many of these principles and formalized them, especially Kent Beck and his cohorts. We're lean in the software sense of lean. Absolutely, Lean Six Sigma has been applied to manufacturing for quite some time. Lean Six Sigma reduces costs, reduces muda, the wastes, and it reduces variance. So you have similar product being produced again and again and again. A byproduct of this process has been that innovation has become expensive, because Lean Six Sigma would encourage us to use that stamped steel die that costs $10 million. Because we'd say, we're going to try to make 400,000 of the same thing, which is the opposite of iterating. By adding Agile to lean practices, we reduce the cost to make change and reduce the cost to innovate. So we can think of extreme manufacturing as Lean Six Sigma and Agile together. This is an Arduino circuit board. It's $24. We use it to replace a computer in our car that used to be $800. That would be compliant with Lean Six Sigma. But then we go a step further. That computer that cost $800 used proprietary programming languages. That means every time someone came into the team that wanted to work with us, they had to take on the expense of learning that proprietary programming language. This Arduino Uno is open source. It uses processing, which is a derivative of C. There are hundreds of thousands of people on this planet that are able to program these devices without any additional training. That's lean in the software sense, where we're reducing our ability to take on new team members and work productively in a short time. We use Agile to reduce our cost to make change. Here's our backlog in blue sticky notes, one of our backlogs. And it's on wall-sized whiteboards. Here we're being filmed by the Discovery Channel. And the card that's going into progress right now says, take the Discovery Channel for a test drive. This is the same backlog where we have our new product development, our hardware engineering, our customer fulfillment, our financials, and our business aspects. They all compete for priority from the same cross-functional team. This means if our company needs to be nimble and go a different direction, we don't have to launch a team to study the effects of that change. We don't have to launch a team to determine the feasibility of that change. We move a sticky note and write a new one. When our entire project management is this agile, we're able to take advantage of market opportunities much quicker than was traditionally thought possible, especially in a manufacturing and R&D company. We use collaborative teams because we found them to be the fastest way to generate new product development. We've settled on Scrum because it's the simplest, least overhead method to manage collaborative teams. In this picture, you can see all 3 roles of Scrum from one of our teams. Our product owner, our Scrum Master, and 3 team members are all in this picture. We do all work in pairs to reduce time spent training that's not productive. We don't create training manuals because we would have to maintain them. We don't show people a video of how to do their work when they join the team. We instead pair them with an experienced team member and have them immediately start creating parts for customers. In this case, we have pairs creating one of our engine assemblies. Mary Papanik, reaction.
Wow!
We've found morale to be a multiplier for velocity. We work on 1-week iterations, which means it's very easy to see when we've made a change in the team that increases our velocity, that passes all quality tests. And we've found weeks where the team reports high morale or happiness. We complete, on average, 10 times the amount of work that passes our quality tests. On weeks where the team reports low morale, or says on average they're not feeling well, We do not produce any work that passes our quality bars in 1 week. It slows down that much. That allows us to prioritize items that delight the team right alongside business value. Our same backlog, that is all of our new product creation, product delivery, and financials, also includes user stories written by our team members just to delight them. A team member might write down, I would like to obtain more mastery in carbon fiber work, and they put that in the backlog. I would like to work with more of our team members in Argentina, and they put that in the backlog. Because we've seen morale as a multiplier for velocity, we're able as a savvy business to balance those priorities with all our business values because of the dramatic impact they have on our rate of new product development. We visualize all our workflow to avoid time spent that's not creatively solving problems. The time between a team member having a good idea and the customer using that idea is all waste. If we can shorten that time and go from idea to the customer using that idea, that would be the ideal world. Kanban allows us to maximize that every sprint by visualizing our workflow. With that, I'd like to introduce Mohan and Naveen from SolutionsIQ Bangalore to give us a 5-minute deep dive into Kanban. Please join me in welcoming Mohan and Naveen.
Hi guys, we did this in a healthcare system very recently. This is a big company and we have done this implementation for them. So the first thing we did was we had a stakeholder meeting. We took the high-level expectations of the team from the stakeholders as to what they wanted to see. And 2 or 3 points that came out was they wanted to visualize the work that was being done. They wanted the team morale to be there in terms of ownership, productivity, stuff like that. And they were also a little confused about how do we measure certain matrices around that. So given these things, we first jotted down those matrices, the expectations, and shared it with the team.
Yeah, one more point to add up is the first thing we did was to sit with these stakeholders to understand what is that they're looking forward in the Kanban board. Okay, so high expectations, high level expectations is one.
Technical difficulties.
Oh wow. It's stuck. Really, really good.
What did you guys do?